Aircraft approaching Frankfurt Airport at a rate of up to 1 a minute. Landing at a busy airport calls for the utmost concentration, and not just from the pilots. At Frankfurt, one of Europe's biggest hub airports, the air traffic controllers of the German air navigation service provider have to keep everything in their sights until the aircraft land and leave the runway. As soon as landed aircraft turn onto the taxiways heading for their parking position, they're handed over to the ground controllers. It's their task to guide the pilots by voice communication. This, however, leads to misunderstandings time after time.
Die Piloten haben alle ihre Karten, können sich daran orientieren.
The pilots all have their maps for orientation, but if they are given a different taxi route at short notice, then it often happens that the pilots deviate from the assigned route and take the wrong taxiway.
Den falschen Taxiweg nehmen.
The controllers manage traffic by visual reference to the aircraft. During peak hours, the radio frequencies are often congested.
New solutions are urgently needed, especially for bad weather conditions at night and in fog.
While moving along their taxi routes, pilots are always under pressure. Any unnecessary delay and every taxi route deviation results in increased fuel burn. And all the green centerline lights, which are permanently switched on, are only of limited help for orientation.
Especially at complicated routings or with several intersections one after the other, it's not easy to know which is the right turn-off, so you have to stop, which interrupts the flow. We keep having to look to see whether we're on the right taxiway, and are always glancing over at the map. We use printed maps at the moment. Are we still right? Or where are we?
In 2007, leading German industrial companies started working with research institutes and airport authorities on a completely new approach to individual routing and guidance. WFF, the Competitive Airport Project, is an interdisciplinary venture supported by the National Aviation Research Programme of the German federal government.
Airports have a clear interest in dependable taxi times, achieved through higher automation, with unambiguous operational procedures, clear visual guides for pilots, and shorter taxiway times, and preferably with energy-saving technology.
Following conceptual design and production of software and hardware prototypes in the laboratories of the project partners, the pre-test phase began in autumn 2008 at the DLR, the German Aerospace Center in Braunschweig. Using cockpit and tower simulators, the system was tested under conditions as realistic as possible. On the controller side, by experienced apron controllers from Frankfurt Airport. And on the side of the cabin crew, by professional commercial pilots of various ranks from various airlines.
This sort of simulation, covering the overall ground traffic context, is important because the entire context simply couldn't be tested in real life. Safety considerations would impose too many restrictions. We're testing visual guidance for ground traffic operations using a flight plan that is typical for Frankfurt Airport.
The experts developed a comprehensive surface traffic management system, including a human-machine interface for controllers, a routing and guidance server, digital navigation means for pilots, data link communication, and distribution line carrier for individual lamp control. ASMGCS, the Advanced Surface Movement Guidance and Control System, consists of just a few components and interfaces. The controller in the tower specifies the taxi routing for each aircraft via the S-man, a central surface manager employing a new type of intention-based human-machine interface. The S-man then transmits the controller's route assignment to the cockpit and to the AGLAS remotes. These remote control units operate the stop bar and taxiway centerline lights a section at a time according to the position of the aircraft. The S-Man at Frankfurt Airport continually receives the aircraft's position from the existing surveillance system. The pilots themselves also receive their aircraft's position signal as usual by GPS. The position of the aircraft is visualized in real time, both on the front ends of the controllers in the tower and on an enhanced onboard navigation system. Route and clearances are synchronized and transmitted by the S-Man via data link in a newly developed data format, supplemented by individual airfield lighting for pilots. Once the controller has given a hold short advisory via the S-Man, taxiway sensors detect any overrun. AGLAS power line communication transmits the sensor signal and the commands to the individual warning lights. The S-Man and onboard navigation system indicate the conflict to both the controller and the pilot. After the conflict has been resolved by the controller and the taxiway is cleared, the onboard display and centerline lights indicate the route to be followed. Final preparations for the first field test of the complete system in September 2009. A runway at Frankfurt Airport has been closed for the purpose. The power supply for the airfield lighting is wired to the new remote control units, which switch on or off individually green or red taxiway lights according to the control command. These remote control units switch and monitor the light fixtures, and they also transmit and receive high-frequency signals via power line communication between the substation and the individual light. The control command is transmitted via the S-Man to a substation along the route, which houses the AGLAS master equipment for the airfield lighting. This passes on the control command to the appropriate remote control units. All airfield lighting fixtures are equipped with AGLAS. Their current status is continuously displayed. For the test, 2 vans have been specially equipped with state-of-the-art air traffic communication and display systems. Each bus contains a replica of the pilot's cockpit. For the wireless transfer of data, VDL Mode 4 and UAT radio systems are used. In this validation phase, the operational procedures and the integrated system solution are assessed by pilots in a real environment.
Continue taxiing. Continue taxiing following the green.
The new S-Man display on the right gives the controllers an overview of all movements on the taxiways. The controllers give the pilots their route via mouse click, individually for each separate aircraft. The pilots just have to follow the centerline lights. To avoid confusion for subsequent aircraft, the centerline lights are switched off again, segment by segment, as soon as the aircraft has passed. This also saves energy and extends the lifetime of the lights.
There's 2 aspects. One is related to the pure light source itself. So the LED lights, it's a much more power efficient source of light compared to traditional halogen lights that you find all over the place still in houses. And the second aspect is a much more efficient use of these lights. So rather than just switching on all the lights all the time, you only switch on those lights that you actually need to guide one particular aircraft.
If the aircraft deviates from the green lines, or if a runway incursion threatens, sensors and additional red LED lights ensure the pilot is given an unmistakable warning. At the same time, the alarm signal flashes in the cockpit and on the controller's display. 3 separate alert signals on both displays and on the taxiway provide triple security. These critical scenarios, typical of real airport situations, were just the dress rehearsal. 4 weeks later, an Airbus A320 from the German Aerospace Center is prepared for the final test phase. On a part of the maneuvering area of Frankfurt Airport specially reserved for this purpose, the complete WFF system is to be tested for several nights under real conditions by commercial pilots who will critically try out the system and record their experience. The passenger compartment contains control displays for the various system components. The A320 taxis to the area where the test scenarios will be staged, some with the new visual guidance system, some without. taxi instructions and clearances are transmitted to the cockpit display via data link. The scenario is to follow the greens up to the next holding position. The information displayed to the pilot on the left and the controller's display on the right are always consistent. This is ensured by the S-man.
The S-man is the core of the information flow. It receives information from the sensors, processes and augments it. It combines information from various data sources, for instance from an airport operational database, and from all this it warns if dangerous or undesirable situations are occurring, and it shows the pilot via an onboard display or via the centerline lighting on the taxiway where he should be heading. So the S-man is the link between incoming and outgoing data.
If the crew overruns the holding position, the system automatically issues a warning to the controller and the pilot.
The red taxi lights are on. Hold position.
While the pilot not taxiing is kept in the loop about the taxiway sections ahead, the pilot taxiing can concentrate on the centerline lights. The next scenario includes a route deviation.
We taxi to November via Sierra. Off to the right-hand turn.
If the pilot leaves the assigned route despite clear visual indication, a warning is issued by the onboard display. At the same time, flashing alert lights on the tarmac indicate the route deviation. The aircraft has been equipped with VDL Mode 4 data link technology for wireless data transfer between the service manager and the onboard navigation display.
For the WFF project, we're bringing completely new information together in the display. On the one hand, the GPS position of the aircraft and the airport data, a database showing the airport in high definition. And on the other, we receive the cleared taxiway for the aircraft in real time via a data link.
The final test is, first of all, to follow the segments of green centerline lights preceding the aircraft around several curves. The onboard display shows the aircraft's position and the cleared taxiway section. The aircraft is now approaching a stop bar.
The runway 18, stop bar ahead, crossing Whiskey.
As experts, the pilots now draw their conclusions about the new ground traffic guidance and control system. Did it come up to expectations?
I think it's the right way to improve safety and situational awareness on complex airports like Frankfurt, or even on airports you don't know exactly because you've never been there.
I'm pretty sure that a system like this would be accepted by the airline operation. And not only the airline operation, because a big benefit as well the airport operation will have, because I think a key issue at the end is to increase the efficiency of the taxi operation on airfields.
There's no doubt it makes my job easier to separate aircraft. Long term, it'll certainly mean shorter taxiing times and lower error rates. With the doubling of air traffic that we already have, I think it'll be absolutely essential.
The decision for or against the innovation is made by the airport operator. For Fraport, it's important to take account of the fact that fuels are becoming scarcer and more expensive, and the need to protect the environment against avoidable emissions ever stronger.
Well, one other great advantage should be the reduction of taxi times, and with the reduction of taxi times, this for the airline, this means more fuel efficiency and saving costs, and for the airport and also for the surroundings, it's a huge increase in the environment, because we will reduce also the emissions by taxiing, and I think this is a very important aspect for us as an airport operator.
Beside eco-friendly use of resources and long-term cost reductions, the system can meet future safety requirements, enhance efficiency and improve the work process by ensuring less stress in tower and cockpit, despite the increase in air traffic volume. Therefore, the consortium partners are already thinking far beyond Frankfurt Airport.
Obviously, the goal is really to implement and to push forward these concepts all over the world. So what we see is that airports all over the world have the same problems. They have the same efficiency issues, they have the same costing problems with power consumption. So testing it here makes it suitable for exploring it all over the world.
Mutter